Working with data. Strings and data types. Hello everyone. Welcome to the third lesson on Python programming basics. In previous lessons, we've already learned how to print information to the screen using print, and even get data from the user using input. Today, we're going to take a step further and dive deeper into working with this data. In this lesson, we'll cover two very important and practical topics: working with strings, how to manipulate text and check its properties, and converting data types, how to change the shape of our data, such as turning text into numbers so that we can count with them. Working with strings. Let's review what strings are. They're just sequences of characters, text. Anything we enter from the keyboard using input is a string by default. Python offers a variety of tools for working with strings. Let's look at the most basic ones. Concatenation, adding strings. Strings can be added or, as programmers say, concatenated using the plus sign. This is very useful when you need to combine several text fragments. Output, hello, world. See how simple it is. We have combined three strings into one. String length, len. What if we need to know how many characters are in a string? There is a built-in function for this called len, from the word length. This function is very useful for checking the length of passwords, names, and so on. Output, phrase length, 20 characters. Including spaces. Indexing and slicing, accessing characters and parts of a string. A string can be thought of as a series of characters, where each character has its own number or index. The numbering starts at 0. Index 0 is the first character. Index 2 is the third character. Negative index, from the end. Output, first P, third, T, last, N. Now the trick. You can get not just one character, but a whole part of the string. This is called a slice. Slice from start to character 7, not including it. Slice from character 8 to end. Output, Part 1, Learning, Part 2, Python. Indices and slices are a very powerful tool for working with text data. String methods, changing and checking properties, .upper, .lower, .strip, .replace, .isupper, .ilower, .isdigit, .isalpha. Strings in Python have special methods. These are built-in functions that perform various actions on the string itself. Some of them change the string, more precisely, create a new modified one, while others check its properties, answering yes or no, true/false. Methods for changing, .upper, and .lower, to change the case of letters. The .upper method converts all letters in the string to uppercase, and .lower, to lowercase. Output, uppercase, hello world, lowercase, hello world. Strip, to remove spaces from the beginning and end of a string. If the user accidentally entered extra spaces before or after the text, .strip will remove them neatly. Output, example with spaces. .replace, to replace one part of a string with another. Using .replace, you can easily replace some characters or words in a string. Output, I love Python. Methods for checking properties, return true or false now, a very important group of methods that begin with is. They do not change the string, but simply check whether it meets a certain condition. The result of such a check is always true or false. We will show how to use them, and in the future, you will see how powerful they are for making decisions in a program. I supper, n.I lower, check whether a string consists entirely of upper/lowercase characters. .isDigit checks if a string consists entirely of digits. This method is very useful if we want to check if the user has entered something that looks like a number. .isalpha checks if a string consists entirely of letters, no numbers, spaces, or punctuation. The .is methods are your string detectives. They help us get information about what's inside the text. String methods are your Swiss Army knife for text processing. Data type conversion, int, float, str. We already know that input always returns a string, but what if the user enters a number and we want to calculate with it? This is where data type conversion comes in. Each value in Python has its own type. For example, hello is a string, str, 5 is an integer, int, 3.14 is a float, float. We can explicitly convert the type of one value to another using special functions. Int converts the value to an integer. Float converts the value to a floating point number, decimal. Str converts the value to a string. Output, type before conversion, class str, after, class int. Now we can count. From string to float. Output, type before conversion, class str, after, class float. From number to string. Output, type before conversion, class int, after, class str. Remember, if you try to convert text that can't be interpreted as a number, like int, hello, Python will throw an error. This is an important point to remember. So, data type conversion is the bridge between the text the user enters and the numbers we want to work with. Theory is great, but programming is practice. Now we'll apply everything we've learned and create 5 interactive programs using input, and the new string and data type capabilities. Ready? Let's go. Example 1, greeting and name check, concatenation, .strip, .isalpha. Task, ask the user to enter a name, remove spaces, and additionally output whether the name consists of only letters. Host, let's start with the greeting, but add a small check using isalpha. Remove extra spaces. Check if the name consists only of letters. Repeat input and strip. Introduce isalpha, explaining that it is a check method that returns true or false. You can show input examples: Alexander, Vazia 123, Olga. Example 2, your age and its type, convert to int, and .isdigit. Task, ask the user to enter their age, check if the entered text consists only of numbers, and then display the age and its type. This example will clearly show why input returns a string, and how isdigit will help us check that the text looks like a number. Check if the entered text consists only of numbers. We will try to convert to a number and add. There may be an error if these are not numbers. If is underscore a underscore number underscore is true, then the conversion will pass without errors. If false, we'll see an error when executing int. Emphasis on the fact that input yields a string. Introduce isDigit as a way to check if a string is a series of digits. Important, explain that int will throw an error if isDigit returns false, i.e. if the user entered letters. This shows that such checks are very important, but we'll learn how to handle errors later. You can even deliberately show the error by entering letters, and then show how isDigit returned false. Example 3, Case-sensitive phrase analyzer, len, .upper, .lower, .isupper, .ilower, slices. Task, ask the user to enter any phrase, then print its length, the same phrase in upper and lower case, and check whether it was originally all upper or all lower case. Combine several string methods to parse the input text, including case checking. Check initial case. Repeat len, dot upper, dot lower, and slices. Introduce dot isupper, and dot ilower, showing how they return true or false depending on whether the entire string matches the case. It is important to show examples where the string is mixed, hello, and both methods will return false. Example 4, Rectangle Area Calculator, Float. Task, ask the user to enter the length and width of a rectangle, possibly with decimal values, then calculate its area. Now let's work with decimal numbers using float. Convert strings to floats. Emphasis on the need for float for decimal numbers. Perform calculations with decimal numbers. Brief explanation of the 2F formatting for rounding to 2 decimal places. Worth mentioning, if the user enters text that is not a number, float will also throw an error, just like int. Example 5, text and number reversal, dot replace, dot strip, dot istigit, str. Task, ask the user to enter a word and a number. Generate, reversed, text, the word in uppercase, and the number inversely, write it as text, replacing the zeros in it with the entered word. Let's finish the lesson by combining dot replace, with our new knowledge of the dot is. Methods and converting numbers to strings. Strip white space. Check if the input is the right type. Show the results of the checks. Flip a word to uppercase. Replace all zeros in number with the entered word. First, make sure it's a string, even if it was originally a number. Demonstrate the use of strip.upper.replace. Show how .isalpha and .isdigit give information about the input. Emphasis on str, explain that we can even take a number and turn it into text. Str, 123, becomes 123, to work with string methods like replace. We don't handle an error if the user types something wrong, but we show how the dot is. Methods help us know about invalid input. Great job! Today we not only reviewed input, but also learned some powerful techniques for working with strings, concatenating them, measuring their length, getting parts of them, and changing them with methods. Most importantly, we learned methods for testing properties of strings, .is, that return true or false, important information that our program can obtain about the data. We also delved into the all-important concept of data type conversion, learning how to convert strings to numbers and back again, allowing us to perform mathematical operations on the data entered by the user. This knowledge opens the door to creating truly interactive programs that can communicate with the user, process their data, and even tell us what kind of data it is. Remember, practice makes perfect. Try modifying these examples yourself, or come up with your own. Try writing a program that asks for two numbers and adds them together, or asks for a name and prints it in reverse order. That would be a slicing call. In the next lesson, we'll finally dive into conditional statements, if, elif, else. This is what will allow our program to make real decisions based on those very tests, .is, that we learned today. Thanks for reading. See you in the next lesson.